So we've talked about how the sample size may affect the quality of the information that you get. Today we're going to consider what strategy would best be able to reflect the characteristics of the population. We're going to look at 8 particular sampling strategies today. This is a good summary of the 8 sample strategies that I'll get you to take down into your books. I'll discuss each of them in a little bit more detail, and there's particularly I want you to copy down the maths behind capture, recapture and stratified, and then we'll finally talk about we'll also copy down random, and we'll do a random stratified sample at the end as well. So a random sample is when participants are chosen at random, often numerically, and they're representative of the population. Accessibility sampling, well, that's just when you go and find the most accessible participants. For example, if I'm in my staff room, I need to ask 20 students about something, I'll just walk out of the staff room and just go to the nearest location or the first 20 students I come across. Systematic sampling is when you use a system to choose your respondents. So for example, every 100th entry in the phone book. Now just be careful with that because if the phone book is full of Smiths, for example, you're going to be choosing people with the same last name. Quota sampling is when we go to subgroups of each of the population, and we're going to choose them in the same proportion. Judgmental is where you make a judgment, and this will often result in bias. Stratified is where we are using each level of the population. So for example, year level, and so that works really well at school, so each grade, and we'll use them in the same proportion to the population. Now that's going to be really good if we use that in combination with a random sampling. Cluster sampling is that's when you go to clusters of the population and you choose the different groups and then go from there. And capture recapture, and this is going to be used in biology, for example, when you estimate the numbers of populations of animals. A certain number of animals are tagged and then released. At the later date, a number of animals are captured and the tagged animals and non-tagged animals are compared. So let's look at the first one. A random sample is when each element of the population has an equal chance of being chosen. For example, the method is just we assign a number to each element of the population, so that'll be each person, and then use a random number generator, such as a random number table or a random number function on a calculator, or just their name in a hat and just randomly select them out. And that will be a random sampling method. So if we have a look here for a random number table, and this is, I'm going to run you through the process here, and this is something you certainly will be tested on. So let's look at the rules. So we're going to begin at any position on the table. So I've just chosen a random position there. Now I'm going to move in any direction. So I could go left or right, up or down. So in this case, I'm going to go up. And I'm going to go along that column or row. And now moving in that direction, recording the numbers as we go. If I've got a 3 or 4 digit table and I only need 2 digits in the selection, I'm going to use either the left or the right or the middle and make the choice, but be consistent with that choice. Now, if the same number is repeated, don't use that number a second time. And I'm going to continue recording until the total number has been reached. So, for example, if I'm looking here, I'm starting off at the bottom and I'm going up. So 94 will be my first number from number 1 to 100. This would be, 0 to 99, because 100 has 3 figures. So then it'll be 41, then 44, then 65. You can see that I'm just selecting the back 2 numbers for each of my random number generators. Then I could choose to go that way, etc. And that would be fine. Just be consistent in terms of when you start off, continue that, and choose the same group of numbers if it's a 4-digit table, for example. For this activity, I want to just show you how to use your random number generator on your Casio calculator. So we're just going to use our Shift and then random number button here. And if we want to go, for example, for 2-digit integers, you'll be faced with something like this with your random number generator. So you need to make a choice of which 2 integers are you going to use. You're going to use the tenths, the hundredths, or the thousandths columns. You're going to choose 2 of them. So I'd suggest use, for example, the tenth and the hundredth column. So this random number, if it were to be between 1 and 100, or 1 and 0 and 99, I should say, it would be 7. We would just press equals again. The second one would be 76, and then this one could well be 0. The next one would be 44, 91, 55. That would be 11, 9, 47, 47 again, 46, and so on. So that's using your random number generator in your calculator. As the name implies, accessibility sample is just getting those items or those people, for example, who are most accessible. So let's consider the following. The student body in a school is investigating extended hours for the library. Now, a survey conducted by students who were using the library after hours overwhelmingly supported the proposal for extended hours. However, the same survey conducted in the gym after school indicated no need for extending the library hours. So, as can be seen from the example, bias can be introduced into the results of a survey by carefully selecting the sample to either support or refuse a cause. And the sample drawn only from easily accessible items does not often represent the views of the population. So it's interesting, for example, Sunday morning TV shows will often put out a sample and for some pretty controversial views. And you notice there's a certain section of the population that actually go to church, for example, on Sunday mornings. So if we watch TV and we see these samples or these surveys, you can know that the feedback there is only going to those accessible to those watching the TV program at the moment. Now, systematic sampling involves a system. So we're just going to line all the sample items up and select, for example, every 10th person or every item on the top left-hand corner of a page or every item in the 5th position in the set of lists. So consider a survey to determine the most popular service provider for the internet subscriber. Sample could be used by ringing a 100th name and every telephone directory, the last name on each page, the name on the top of the list of each names on every page. So using the telephone directory to obtain survey data has the obvious disadvantage of excluding those who don't own a telephone or those with an unlisted number. When using a systematic method as a sampling technique, best results are obtained if the population is first arranged randomly. Quota sampling is just filling a quota. So consider this one. A group of businessmen is considering establishing a grammar school in a town of about 50,000 people. They decide to market a survey of 1,000 people. They specify that the composition must contain this many. It's got to have 500 males and 500 females. Within each of those groups, there should be school children and half adult. The groups must contain religious denominations, not in equal proportions, as they don't occur that way in the community. And from the 500 children selected, there should be 200 from non-government schools and 300 from government schools. So, within the specified quotas, the person responsible for choosing can sample any other way. So this leaves the sample open to bias because it depends on the integrity of those selecting the sample. It also enables substitutions to occur when those originally selected for the sample are not readily accessed. Bearing in mind the problems associated with this type of sampling though, this method can prove quite cost-effective and reliable if the composition of the sample is appropriate and the sample is selected in an unbiased manner. Judgmental sample is based on a judgment of the person conducting the survey. So it's obviously reliant on the good person or the good judgment of the person selecting the sample. So consider undertaking a survey for a bus service in a city or town. If a judgment was made to select a sample from only those who use the service, this could result in an entirely different outcome from what might occur if there'd been a balance between both bus users and non-bus users. So consequently, we've got to be aware of surveys conducted using this technique. And it's timely to reinforce that we are often bombarded with these statistical facts, and we've got to be careful not to accept each of these figures without question. Stratified samples. Now this is going to be one we'll focus on a bit. So when a sample is selected from a population consisting of various strata, for example grades within a school or ages, it's important to have the same strata or levels occurring in the same proportions as they do in the whole population. So let's consider the situation where a student council body is to be formed from year 8 to 12 students in a school. It would not seem fair to have an equal number of year levels if there were, for example, twice as many year 9 students as there were year 12 students. So we see strata over here, as we can see here, these different layers, and a strata is just another word for a layer. So let's have a look at this example here, and this is a maths one I want you to copy in, please. So a large school has 162 year 12 students that study maths A, 95 that study maths B, and 32 that study pre-voc. A survey is to be conducted that requires various participants to be chosen from each subject in the same proportion of the population. How many from each subject should be chosen if it's to be 20 participants in all? So we look at all of those year 12 students. So we've got 162 from maths A, 95 from maths B, and 32 from pre-voc. So there's 289 students. So we want to now consider the proportion, and so we're going to make a fraction out of this. Our fraction will be, for proportion, we always put the part over the total. And then we're going to multiply it by the desired sample size. So to work out the proportion, you put the part of the population, for example 162 maths A, over a total of 289 maths students, and then we're going to multiply it by 20 students in all. Now that's going to get 11.2, so we just round it off, so we say that's approximately 11 students. Now for maths B, there's only 95 students, so we're going to put the part, so the part is 95 this time, over a total of 289, so that's 6.5 students. We'll round that off to 7, and then 32 pre-voc students. So we've got 32 over 289, and that's going to be 2.2, and so that will be 2 students. So we've got a problem here. What's that? 11 plus 2 plus 9? No, that's good. I can count. That's a total of 20 students. And so 11 students from maths A, 7 from maths B, and 2 from pre-voc would be representative in this survey. Now, we would choose them randomly for a stratified random sample, but we can also just choose the first 2 of each, for example, for pre-voc, and that would open it up to bias if we actually made those selections there. So it's important to choose these randomly and have a random stratified sample. The 7th method is cluster sampling, and this involves selecting clusters within a population. And so these clusters or subgroups have to be identified. So let's have a look. at a situation where a survey is to be conducted on the cost of a tertiary education. If the chosen clusters included only the ones from poorer areas of the community, the results of the survey would vastly differ from those from the richer areas. So it's important then with this method of sampling that the clusters are chosen to be closely representative of the population as possible. So in this case, the survey can be quite reliable in a far shorter amount of time with a greatly reduced cost than collecting data from the whole population or census. This method here, the capture-recapture sampling, is the final method we're going to look at today. Now, it's particularly useful for estimating populations of organisms out in the bush, for example, that are impossible to count, such as plants or animals. So when we monitor wildlife numbers to think about plagues or extinction of species or so on, we use this method to estimate. So we also can think of it as tag and release. Now the capture-recapture example that we're going to look at is going to be a fairly high order question that I'll test you on later. So let's look at this example. In a particular area, 200 kangaroos are tagged and released. Now later on, 80 kangaroos are caught, 24 of which have been tagged. We're going to use this to estimate the population of kangaroos in the area. We're going to use this by using equivalent fractions, and so here's our two fractions here. Now the only one that we do not know is I've highlighted in red here. So let's look at this information and work this out. So on day one, so here's day one, I've caught 200 kangaroos. Now of those 200 kangaroos, I don't know the whole population, so I'm just going to put 200 over K. On day two, which is any time later, we've got some more information. We've got 80 kangaroos are caught, so that's the size of the sample caught on the second day. Now, 24 of those have been tagged. So we can now do a little bit of algebra to work this out. So we know that our equivalent fractions is like saying 200 over K equals 24 over 80. So let's rearrange this equation now to say 24K equals 200 times 80. Can you see that I have just swapped around a couple of things? So I've said K times 24 equals 200 times 80. And then I can move this 24 to the other side of the equation, doing an inverse operation. Now the inverse is the opposite, so instead of multiplying by 24, I'm going to divide by 24. So the final way to consider this is K equals 200 times 80 over 24, and so that will equal 667. And we can use that process now to estimate that there's approximately 667 kangaroos in this area. If we have a look at another example, in the ratio of males to females in a given city, how many males and how many females should be selected for a sample containing 800 people? Well, let's consider the strategy to use. The strategy should be a proportional one, so that's a stratified one. So we think of the total. The total is 95 plus 98, and then the proportion of the males is going to be 98. So we've got the part over the total, and then we're going to multiply it by the sample size. So that looks like a stratified sort of question there, because we're asking how many should be in proportion. Now I'm going to get you to work on the supplementary exercise. It's actually from the old textbook, but they've called it a supplementary exercise in this one. And to work on this activity, you'll just need to click on this Acrobat document here, the PDF, and it should open up for you, and you'll be able to look at the exercises there.